Hi everyone and welcome. I'm Jumana Saidani, the moderator for this panel. Now we've reached the third and last day of the event, starting it with a panel titled Geoscience Approach to Net Zero, supported by three experts from different backgrounds. Ladies and gentlemen, please welcome our panelists, Mr. Amine Nabi, Mr. Nabil Meddour, and Dr. Said GACI. Proceed in alphabetical by their names. Mr. Amine Nabi is a geoscience technical advisor with Landmark, Halliburton, and his past Halliburton office in Algiers, holding master degrees in geoscience from the University of Boumerdes. Mr. Nabi started his career with Halliburton as a geoscience consultant in 2014. He worked across a diverse range of teams and subsequently managed the landmark geoscience of product. Moving to the second panelist.
Hello, everyone. I'll be honored to introduce you our second special guest of today. Mr. Nabil Meddour is the North Africa Schlumberger Geosolution Manager and a geophysics engineer graduated from the University of Science and Technology Houari Boumediene in 1991. Mr. Nabil oversees subsurface imaging business. It includes seismic processing, seismic reservoir characterization, server design and modeling, and multi-physics services. He started as a geophysicist in 1991 as a quality control and supervisor for Sonatrach exploration. Then he moved to seismic processing geophysics, where he involved AVO analysis early in 1994. He was also involved in many processing and reprocessing projects. In 2005, Mr. Meddour joined Schlumberger as a data processing project leader, then supervisor in 2007, and finally to manage Schlumberger Processing Center based in Algiers. During his journey, he was involved in different imaging projects for Sonatrach and its partners. The workflow was developed to include depth imaging and seismic reservoir characterization that it is used largely in Sonatrach. He is a stakeholder within Schlumberger organization for the digital transformation. Jumana, I give you the mic again.
Now to our and last panelist, Dr. Said GACI. Mr. Said GACI received the diploma in geophysical engineering and the magister degrees in the petroleum economic and strategic management from the Algerian Petroleum Institute Boumerdes in 1997 and 24 respectively, and the magister and PhD degrees in geophysics from the University of Science and Technology Houari Boumediene and 2002 and 2011, respectively. He worked in Sonatrach Exploration Division as a senior geophysics from 2004 to 2015. He joined Algerian Petroleum Institute in 2015 as a head of development and preservation department. Certainly, Mr. GACI is reporting at the Petroleum Institute for research and include an application of senior and veteran degree in science. Now, ladies and gentlemen, I would like to remind you that this session is being recorded and we will share it on LinkedIn. Also, I would like to fill the attendance sheet that we will share it in the chat box. Mr. GACI, can you hear me?
Yeah.
Yeah, the mic is yours. You can share your screen and start your presentation. Good luck.
Good morning, everyone. I'm very pleased to be with you today to present my lecture. Is it okay?
Wait a minute.
Do you see my presentation?
Yes, we can see your presentation. Yes,
as I said before, I would like to extend my thanks to SP student chapter for their initiative and for their efforts to organize such scientific events. I'm very pleased to be with you to share my ideas and my lecture that I prepared just to give you just a global idea regarding the major trends in exploration geophysics. I will be discussing the main tendency in exploration geophysics. So in my agenda, I have to present first just a brief introduction, followed by presenting the text analysis based for determining trends, followed by followed by giving insights in main trends in exploration geophysics, followed by concluding remarks. At the end, I will give you some further reading references. I will be focused on seismic exploration methods since it covers the main part of geophysical methods. So geophysicists currently contribute to asset teams and service companies in a wide range of ways. This is mirrored by the many uses that seismic has. So the traditional 2D and 3D seismic is key for exploration and development workflows. So modern acquisition and processing techniques have enabled high quality illumination of subsurface for conventional and unconventional reservoirs at much lower costs than in the past. The second application, here we have pre-stack workflows such as EVU, which is used to predict fluid properties and the localized stress and the fracture orientation. Thirdly, we have the seismic attributes and quantitative geophysics, which can be used to predict localized stress regimes for distribution, optical property integrity, and can further be used to highlight statistical relationships with pay and reservoir quality through cross correlations. Then the next one, we have 3-component seismic, which is used to predict fluid distribution, rock properties, and change in lithology. Another technique, seismic technique, which is a 4-dimensional seismic, 4D, which is routinely used to measure the effectiveness of enhanced recovery programs. We have also microseismic imaging of hydraulic fracturing, which is used for improving fracture designs and well completions and optimizing the spacing and sequencing between offset wells. So in an industry where producing companies are adopting decision tree and value of information analysis in an effort to objectify decision making, cost-effective and highly accurate methods for reducing risk are very important. So geophysical methods have on reducing risk in an economical way, even in situations where risk is fairly low. So here, I would like to say that geophysics has changed considerably over the last 3 decades, and an increase in computing power and technological progress allow geophysicists to solve the ever more complex task. So evolution of professional language reveals advances in geophysics. So researchers eagerly describe new methods of surveying, data processing techniques, and objects of their study. In fact, tracking change in the professional language allow one to identify trends trends, and current state of science. Each annual conference or publications give us a snapshot of the state of geophysics, and these snapshots are used for analysis and predictions. So here, this paper that I used to prepare my presentation present an application of language processing method to analyze change in the professional language in geophysics. In total, we have more than 21,000 papers published from 1990 to 2019 have been analyzed. They consist of more than 52 million words and phrases, and corresponding to more than 347 million samples. The main results of this paper is to give to present an open access database, presenting an example of how this database can be used to identify and summarize the processes taking place in industry and science. So through this paper, this study presented in this paper, we can extract an idea, have an idea about the main trends in geophysics by analyzing words and phrases becoming more popular, and in the same time to have an idea about topics which are being used less in time. So the paper here, the results presented in the paper show us that during the 3 decades, the most geophysical method used in geophysics exploration is seismic with 74%. Seismic methods can be part in the magnetic and electromagnetic, then gravity prospecting, allowed by electrical methods, and at the end we have logging while run recording methods. In the same time, we have presented here, the authors present the frequency of words used in the papers. So from 19 to 2019, we have in blue the word gas, which is the most used here, which is relatively important regarding water, and coal, which occupies the least importance in this study. Regarding the analysis of engineering geophysics, it has been shown that the near surface methods are the most important compared to engineering and groundwater and quartz. In the same time, here we present environmental geophysics, which is very important compared to the other disciplines investigated in the paper. Here the results are related to the change in the use of seismic data processing methods. As can be noted that we have the most important here, we have the full waveform inversion, which is gaining an increasing importance during the last years, followed by the reverse time migration, and at the end, with less importance, we have the pre-stack depth migration. Regarding the frequency of the abbreviations used in the investigated documents. We have the full wave inversions, FWI, which is very important during the last years, followed by reverse time migration, RTM, and at the end we have post-stack depth migration, which occupies the least importance, the lowest frequency occurrence in the investigated papers analyzed during this period. In the same manner, we have analyzed the different terms regarding seismic data processing and algorithms. So as can be noted that the machine learning is becoming very important during the last years compared to the broadband seismic technology. And the different terms like seismicity, Marchenko, Markov, and augmentation. In the same manner, we have analyzed the different terms used in seismic processing. So here we show the different decline tendency of using Kirchhoff migration, the term CMP, and the normal move out corrections, and velocity analysis, and at the end, interferometry. And here we presented the results, the different results regarding the use of neural network in processing seismic data. Here we can note that neural network algorithms are very important, has been used widely compared to the other terms. Here they are very frequent compared to deep learning, artificial intelligence, and field data. And in the same manner, we have presented the evolution of using the different phrases: convolution neural, training data, machine learning, and deep learning, training set, learning method, and neural network. Here again, we confirm that neural network phrase is the most commonly used during the last years. And here to summarize the main results of the paper, here we show that the term shale is the most commonly used compared to the phrase neural network, or fracking, or fiber, or the term unconventional, and total organic carbon, and the Marchenko algorithm. Here to end up my presentation, I would like to say that facing an ever increasing demand for improving accuracy and reliability, further development of geophysical technologies for oil and gas exploration are focused on the following topics. The first one, which is the broadband digital seismic data acquisition technology, which includes accurate and the broadband vibroseismic source with low distortion. It includes also full band digital seismic sensor, digital multi-channel recording system, and different open platforms for seismic acquisition. In the second topic, we have technologies for building rock physics model of complex reservoirs, which includes all the models related to different lithologies. with their corresponding software tools. Thirdly, the important topic and the important tendency, which is high accurate amplitude preserving seismic imaging technologies, which includes real reverse time migration, full wave inversion, as well as relevant techniques in noise reduction, true amplitude recovery, and accurate velocity model building. The fourth tendency, which consists to use more integrated interpretation technologies for complex reservoirs. And here we are talking about rheostat seismic migration, high resolution seismic inversion, petrophysical property inversion, also fluid detection, and integrated reservoir evolution and dynamic and static reservoir modeling, as well as integrated modeling of complex structures. In the fifth point, another tendency which consists of using other seismic geophysical technologies such as gravity, magnetic, and electrical methods. And here we are talking about equipment and software for high resolution, three-dimension electric and magnetic survey, velocity model building, and structural interpretation constrained by non-seismic data. Also software for joint seismic and non-seismic inversion, as well as engineering seismic technologies such as micro-seismic monitoring. And the sixth tendency, which is dynamic seismic guided drilling technologies, including fast and efficient dynamic seismic prediction and the ability to make real-time update of the predicted seismic results based on the latest drilling information, hence to adjust the drilling trajectory and improve the success rate of deep drilling. And at the end, an important tendency, which is the introduction of the different big data and the machine learning algorithms to process and extract meaningful information from geophysical data. Okay, I would like to thank you for your attending, for your time and patience, and I'm available and willing to answer your questions. Thank you. And here are some references.
Thank you so much, Dr. GACI, and thank you so much for your presentation. And now we can pass for the question. As Mr. GACI has an emergency, he can't continue the session to the end. So now we can start the question to his presentation. Anyone has a question, please raise your hand and we can open your mic and ask Mr. GACI directly. We have a question here in the chat box. I can read it. So here we have, I noticed he said here, who is him? Lister, I guess his name. I noticed significant growth in the use of the ML from 2020 2010 and upward in data processing? How was the done of in the past?
Which slides?
A question in the chat box.
Yeah.
He said, I don't know if you can, Mr. Lister, I guess his name. Please, if you can raise your hand and ask Mr. GACI directly, because I don't know, I don't understand your question. For me, it's not clear. I don't know if for the Mr. GACI clear or not.
I think that from 2010, I think that machine learning algorithms has been widely introduced in different platforms and software. I think that this is why we can find it more frequent compared to different terms here like broadband, seismicity, and other terms. And machine learning has been introduced even for predictions, lithofacies, and for processing algorithms like inversion, for clustering data, rock typing, and others, etc. So we have very wide and large applications in geophysics during the last years.
We have here Jafar. Farah, please unmute yourself and you can ask.
Hello?
Yes, someone raised his hand, so please unmute yourself and ask the Dr. GACI directly. Yes, we can hear you.
Hello, good morning, doctor.
Good morning.
I am Jafri Mohammed, Junior Petrovic from Sonatrach. I am wondering for if you have in EAP, if you have any lab of the inversion already working or any project of the inversion in EAP?
We have just begun by doing this, yeah. But just recently we have begun to introduce and to perform seismic inversion. But you can contact me later. You can contact me later. There's no problem.
Okay, thank you. Thank you, doctor.
Yeah, thank you.
We have other question in the chat box here too. He said, do you think that ML can totally do an action? Autonomous, oh, I don't know what's this. Without human in the interaction of geoscience and drilling in the future?
I think that we can't leave machine learning algorithms do the different tasks alone. I think that they have been they should be controlled by engineers, by geoscientists. Otherwise, the results might be erroneous and mistaken.
Okay, I have a question. Okay, so thank you so much, Dr. GACI, for your interesting presentation and for being with us today. Actually, I have a general question about Sonatrach. What do you think Sonatrach is doing to support decarbonization and the clean energy goals and this road to net zero emissions? Do you think that this is the time or not to think about it, since that the barrel is at $100? Or I just want to have your opinion on the subject.
Yeah, thank you.
Thank you.
Today I presented just the technical issues, and your question maybe should be asked to another. We have another department regarding renewable energies, and I think that it will be the best person to answer you. But I'm not authorized to answer you about this question.
Okay, I got it. Thank you.
But we can discuss later if you want. You can contact me later. There's no problem.
Okay, I will. Thank you, Mr.
Thank you for your interest.
Thank you.
Thank you. Anyway, remain available if you have later questions. You can contact me by email, or you can join me by LinkedIn or Facebook or ResearchGate. We have my coordinates here on the presentation.
Okay, thank you so much, Mr. GACI. Thank you so much for your presentation. It's an honor to having you here with us today. So no question in the chat box, I guess. They all thank you so much. And now, now we can pass for the. Thank you so much for attending us today. Thank you so much. And we can pass for the second panelist for today. Mr. Meddour, I guess he's the second panelist to share his screen. I ask you for share your screen, please, and start your presentation.
No, it will be Mr. Nabi.
Nabi, I'm so sorry. Yes, it's okay. It's fine. Thank you so much, Kader, for correct me. Mr. Nabi?
Yes, I'm here. Please let me know when you can see my screen.
Yes, I will tell you. So now, Mr. Nabi, as we planned, we continue for the third panelist, and we do like a discussion in the end, if you have time, of course. Are you agree with me?
Yes. So today I will be presenting to you. Can you hear me clearly?
Yes, we can. The mic is yours. Good luck.
Thank you. So today I will be presenting to you our Halliburton landmark digital twin or subsurface digital twin vision. So it will not only be related to purely software, as I'm representing let's say the software arm in Halliburton, which is landmark. So we will be going through. We'll be going through the agenda of the slides, be presenting some of the key customer challenges. Then we'll be following up with the subsurface digital twin as we can see it in Halliburton. Then we will wrap up with a quick summary. So we'll be working together with different customers on different consulting projects, and we clearly could find out some of the key customer challenges. There will be always struggling in regional interpretations and regional insights. This can affect clearly the understanding of the different basins, how it's working, how is the mechanism of the petroleum system is working. So a better understanding is always a key to a better understanding of this of the reservoir. Also, handling a larger data sets. We are seeing now a huge amount of gigabytes, terabytes, petabytes of seismic data, and we clearly need better resources to assess this data, to process this data, and interpret this huge amount of data. Also, since we are moving forward to shale, to unconventionals, so we need to quickly to have decisions, or to have better decisions in a very quick time. So we need to reduce the G&G interpretation lifecycle using, well, we'll see, we are moving from classic interpretation on papers to workstations. Now we are seeing, we see more integration of machine learning and artificial intelligence. And in the end, you can see that multiple subsurface representation, if you can see that anyone can interpret seismic or any kind of data, but the interpretation can vary from one interpreter to another, from certain experience to an expert, and this is due to the inefficiencies in the workflow repetitions. So let's start off with the subsurface digital twin, as we can see it in Halliburton. So why it's important? Because we need to enhance the regional insight to reduce the subsurface risks. We also need to have this digital twin to endorse the consistency from basin to well bore scale. So an understanding of the subsurface, not only on the basin scale, but we start with the basin scale or the globe scale, and we move forward to get to the pore scale. Increase the collaboration. Mr. GACI has mentioned this in his slides. So the integrated interpretation workflow can help to validate the different interpretation and move forward very fast in the decision-making point. Improve also the efficiency and reduce the cycle time. So this is also important. If we have better tools, if we have faster tools, so we will have more time to analyze. So instead of having a longer time to interpret and assess the data, we will reduce this time to have a longer time for analyzing the data and understanding the behavior of the different input of the data. And finally, the retention of company knowledge and best practices, and this is very important. You can see that after like 20 years ago, there's a lot of experts that moved out from the industry, and we start losing a lot of expertise in the business. And this is important to retain all this knowledge and keep those information in not only, I'm not specifically in terms of people, but the knowledge should always stay and persist in those workflows. So I will be showing you a couple of let's say interest and points in our digital twins. So it will be starting with a play assessment. So we will be moving from the globe scale, and then we integrate or move forward to the field scale, and finally we finalize with the pore scale, which is the interaction or the importance of each pore in your reservoir characterization. So for each challenge that we have discussed earlier in the presentation, there is a kind of workflow or discipline that can afford it. So if we talk about the first regional insight issue, so for this purpose, we are working on, let's say, about 10 years ago, we started working on this. It's a regional stratigraphic workflow. So it's called NEFTEX predictions, and mainly what is NEFTEX? So NEFTEX, we are collecting all the data, the public data globally, and we are interpreting those data. We have big teams of geoscientists that interpreting the data. So we are interpreting the tectonics movement, moving forward to create chronostratigraphic charts, interpreting the seismic, some of the seismic data and the well data to get regional insights, like one of those grids here. You can see Algeria clearly here and the North Africa. And also the paleoclimate also changes, and this is important to get an understanding also you can get back to any time scale, and precise or understand what is the geology, what is the temperature, all those different effects. So it can give you a real understanding of what can be or what happened in any time durations. And what is important also is that this kind of tools can help also not only in oil and gas, but it also helping in geothermal industry, in mining industry. So it could be also used in different industries. The same tool, since it's using different kind of data, different inputs, it can be used also to put together some of those maps that you can see on the right corner of the slide. So this map is a chance map. So whenever to get this, you have to run different scenarios, starting from precising what is your reservoir, what is I mean, all the aspects of your reservoir, what is the layering, all the say the information of the reservoir, and it will be collecting using some machine learning techniques. It will be collecting the data from the databases and run different scenario and get you this kind of maps. So everything is on the cloud. So this is a very cloud-based solutions that can be run in like a web-based browser or any kind. So you can imagine how can be helpful to if I'm interested to for example to explore or to work in a region. I can run this simulations, get where is the let's say the best area to invest in, and I will move forward to this area and invest or do more let's say exploration or development. Now we'll be moving to the second phase, which is the geophysical interpretation. And here mainly there is two new things that we will be introducing, which is seismic engine and assisted interpretation. So those couple of tools are dedicated, they are completely cloud-based solutions. So all the engine after this solutions is based on the cloud. All the calculations are cloud-based. So seismic engine is a tool that can help you to automatically run different sophisticated attributes. The purpose is to have less time of calculations. Usually, if you are working on, for example, 5 GB of seismic, it can take in a good workstation something like 8 hours. But with the big amount of data that we are receiving nowadays, we can easily get seismic data of 600 GB, and in the cloud, it can take 4 to 5 hours. But if you can run it in your workstation, it can take ages. So the difference is completely huge. So we have done some tests. We tested in 1 TB of seismic data, and it runs perfectly. So the idea is that, as I mentioned before, if you are waiting all this time to finish a job, you are losing a lot of time machine. So the idea is to reduce the interpretation life cycle, to get more time for analyzing and understanding of your data. So we will be decreasing the computation time to up to 90%, compute very sophisticated and complex attribute, and of course shorten the project life cycle up to 10%. Same now, if you have these tools that can help you to create a very sophisticated seismic attribute that could be helpful for horizon and fault interpretation, there is another tool that is following, which is the assisted or fault interpretation. So here we are using some machine learning techniques and algorithm to interpret automatically this seismic attribute. So there is a paper here that you can download and learn more about this algorithm. And the idea is that the algorithm is calculating or creating different kind of seismic attribute, merging them together. Then it will start with a synthetic fault level to create a training model. This training model will be updated in different iterations to finally get a predicted fault interpretation, let's say, module or volume. Of course, whenever you are integrating real data, this machine learning trained model will be updated to predict your or interpreting this data accordingly. So this is some of the interpretations that we have done. This is a basic seismic attribute, and you can see here the last one, how difference is and how I mean the clarity of the interpretation of this machine learning technique. So whenever this volume is extracted, so there will be another tool that will be extracting those fault in fault planes and real interpretation. So this is a quick demo that I want to share with you. So this is a seismic data, and here we are moving in the time slice. And of course, what will happen is that we will push this. This is a basic seismic attribute. And you can see that there is it's not really clear. There is a lot of things that we can update. So this is the solution, the web-based. It's a web-based solution. You can go select your data, upload it to the cloud, select more information about the data. It will be updated, uploaded, sorry, to the cloud. Then you have different kind of algorithm that you can precise. Whenever you are setting your algorithm, the parameters of your algorithm, you can set like a cascade of different algorithms. So for example, you can get the data, pre-process it, make some conditioning on the data, run different attributes to get that by the end an output. So all this can be reduced to only one workflow, and this is what we are doing here in this demo. So just to move a bit forward, so this is the data selections and everything. So and here the first iteration looks better now. So you can see clearly both are extremely better now. But if we run now the machine learning fault prediction, you will see that. So here we are selecting the training model and the seismic data that we want to train using this model.
Yeah.
And this is the output of the seismic or the machine learning attributes. I will be moving to the last part of. So this is the. I will stop it here. This is the let's say the codes of the algorithm, which is good is that it's completely open, so we can adapt it to different locations or different types of data, carbonates, plastic. So it could be easily changed. And whenever we are having this part of data, we can extract those faults directly from this attribute. So you can see by the end here, this interpretation was extracted directly from the seismic attributes. Okay. Now I'll be moving to the assisted horizon interpretation, which is also something that we are hearing about a lot these days. So horizon or assisted horizon interpretation is also based on machine learning. So it's mainly starting with picking the seeds from the seismic. So you have your seismic data, it will pick all the different amplitude, so as seed points. Then we will be analyzing those seed points to create patches. So those patches is kind of trends. Then if you have lithology information, if we have some wells data, it can be using the, let's say, comparing the patches that we have from the seismic data and the data from the lithology to create some GeoAgis model. And based on this GeoAgis model, the interpretation will be interpreted directly. So it's especially this third part, it's really important if you are dealing with stratigraphic layers. So it will be really interesting, and the result will be much better using this GeoAgis model. Some of the case studies that we have run in our region, so Middle East, North Africa. So we have done a couple of POCs, so proof of concepts, and one of the customers, when we ran this, so we could interpret it around 400 faults in hours instead of months or weeks or months. And also the same machine learning technique, we use it to interpret 40 horizons in one day. This is something that probably sometimes you can take 1 day to interpret only one horizon. So 40 horizons in 1 day it's reducing the seismic interpretation by around 40%. And imagine this 40%, we can take it to analyze the interpretation, analyze the basing, the field, and get more insights from the data that we have. Now I'll be moving to the geological interpretation. And for this part also, we keep talking about machine learning and artificial intelligence. And for this type, we are building a complete environment, which are calling it assisted well interpretation. It's consisting of having 3 different tools. The first one is the assisted lithology interpretation. So basically, this tool is a supervised machine learning algorithm that we use it to calculate the probability of lithology in any well. So we just need to put the logs, and the interpretation will be based on a machine learning training model. So then this training model can be a global training model, or you can restrict it to regions and areas, and it will be much precise in this case. The second tool is the chronostratigraphic manager, which is the engine that give you details about the geological data. So the relationship can be, can be stored between the first tool, which is the assisted lithology interpretation, and the chronostratigraphic manager to get a logical interpretation of those data. And the last one is the assisted well correlation, and this is a data science technique that is called time wrapping. So we are analyzing the different, let's say, the different locations or the different responses of the data, and those responses will be directly analyzed to get a better interpretation of the different seismic data. So whenever you want to interpret like a top, like a top reservoir or any layer, so sometimes it's a bit complicated to get the right interpretation. But this tool is giving you a machine learning technique to wrap up different information from different logs and give you an uncertainty or low uncertainty on your interpretation. Okay. So this tool can also predict the lithology and improve your prospect evaluation. It can clearly enrich the interpretation of your results. and reduce the costs, and of course, accelerate your time. This is a very fast tool since it's based on the cloud and using machine learning technique. It can interpret up to 1,000 wells in a couple of minutes. And I will move to the last point, which is the subsurface model or the Earth model. And here we are talking about the scalable Earth modeling, which is a new technique. So usually what we are doing is we are building a model. So and we are upscaling it to small cells, and those cells will be simulated with different parameters. So the idea now is to build another type of models. So this model can reduce the modeling decision-making cycle because it's based on the cloud, and it's very fast to build this model. We'll be maintaining the data fidelity because we are not using anymore this upscaling technique. So the data, we are using another technique which is a bit, let's say, a bit close to the flattening. So we are moving from the XYZ domain to WVZ domain. So it's a bit of flattening the data, putting the right information, and get back them to their location. So it's called the gridless modeling. So there is no grid anymore. That's why we are keeping the fidelity of the data. So there is no reducing of the fidelity or of the data. There is no data limitation. So if you are running a field scale model or a basin scale model, there is no limitations since it's running on the cloud. If you are working on 1 million cell, 2 million cells, 100, 1 billion cells, there's no limitations since it's running on the cloud and can be performed successfully in the cloud. And also reducing the traditional time workflow for Earth modeling, because a lot of or a big part of the workflow is reduced because we are changing completely the workflow to another way. So this is the grid-based model. So usually we are building a model, creating those cells, and put together those information and upscale it, and simulate those different parameters on the different. So this is part of the scales. And you can see, as you can see, if you are dealing with some stratigraphic layers, you will be losing the resolution of the data, and we are losing barrels, and we are losing reservoir. So what happened is that we are moving to a gridless model where the resolution of the data is keep the same. And whenever we are moving forward, this is the grid-based model. We will upscale it, but even with the upscale, we are losing the data. But if we are working with the scalable Earth modeling, we are always working on the same amount or the same resolution of the data. We can even get it better, and by the end, we can have a better understanding of the reservoir. The subtle reservoir and the stratigraphic reservoir can be mapped easily. And in this case, we are not only working on the classic technique, but we are using another technique, which is the gridless model, to understand those subtle reservoirs that we ignored in the past. So by the end, those different techniques of the digital subsurface twin of Halliburton landmark can increase the productivity up to 60%, reduce the G&G lifecycle interpretation up to 50%, and can clearly handle petabyte of seismic data. And by the end, we will have only one subsurface representation that can represent the truth of your subsurface interpretation. Thank you for your time and your attendance.
Thank you so much, Mr. Amine, for your presentation, for your great presentation. Thank you so much. Now we can, I would like to pass to the third panel. After that, we can do a discussion about with the participant and their questions. Okay, thank you so much. Now, Mr. Meddour, can you hear me?
Yes, I can.
Yes, you can share your screen and start your presentation. Good luck.
Sure, I will do. I will do.
Okay.
Uh,
I want to remind you guys to fill the attendance sheet that we shared in the chat box. And thank you.
do you see my screen?
No.
No, not yet.
No, not yet. Yes.
Okay, I think this one. And now?
Yes, perfect. We can see your screen.
Excellent, excellent.
Good luck. Thank you so much.
Good morning, everyone. First of all, let me thank you for giving me the opportunity to share with you my thoughts on the current subject. And the current subject, by the way, as I understood, is how geoscience can help to net zero, which means reduce the gas emission to the environment. Correct me if I'm wrong. And this is the subject that I would like to share with you. I have just a few slides to cover this talk. It's mainly a discussion that I would like to have with you based on my experience on this domain, and let the attendees aware of how our business, oil and gas, is impacting the environment, and what are the actions that we are taking to reduce this gas emission. And hopefully, following the presentation, we will have exchange discussion with the attendees to elaborate more what is going on in the industry with regards to gas emission reduction. I will give you quick information on what Schlumberger is doing right now to achieve net zero by taking serious actions such as reducing the number of bases in Algeria. You can imagine why we do this, because we'll have less office, less rooms, less bathrooms. So there is behind this power saving, and consequently reduce the CO2 emission. Continuously, we organize within the organization workshops to educate employees to optimize the usage of energy. Most importantly, Schlumberger acquired recently a startup dealing with energy transition. This startup uses the technique of getting hot water from underground and pump it to heat houses and offices. The first exercise that has been done within our organization is to transform our offices in Paris into this new technique to remove all the heaters that use electrical power. And you can imagine how we saved the energy and how we participated in this CO2 emission. I will share with you that I like a lot. It's a story of Hummingbird who saw a fire in a forest, and you can imagine how he's a bird. He didn't give up, and he tried to stop this fire by bringing water, very, very small quantity of water to fight this fire. In the meantime, all other animals, much bigger, like elephant with a big tank, who can bring much more water, they were standing, they're helpless, and they are saying to the hummingbird, what do you think you can do? You are too little. This fire is too big. Your wings are too little, and your beak is so small that you can only bring a small drop of water at a time. But as they continue to discourage it, it turns to them without wasting any time, and it tells them, I'm doing the best I can. This is what this story came from the Professor Wangari Maathai, who is the 2004 Nobel Peace Prize laureate. Why I'm telling you this story? Because I will drive you to an area where anyone can think that maybe it's not really an area where we can consume a lot of energy. Therefore, we don't, I mean, put the CO2 into the environment, impacting our planet, because it looks a very small business compared to what we think they really impact the environment. Because when we talk about CO2 emission, we think immediately on industry, cars, steel, a lot of stuff that use a lot of energy. And we think also about transportation. Where I want to drive you is the domain where I'm working, where domain of my expertise, which is seismic business. And we talked a lot about seismic business this morning through Mr. Nabi presentation and Mr. GACI presentation. We talked about huge amount of data that we are acquiring, we are processing, then interpreting. We talked about the machine learning that was developed these last years, and artificial intelligence to reduce the duration. And also we talked about all the techniques, the very complex algorithms that we are using while processing or interpreting. And this will drive me to the following statement. You know that for processing, seismic processing, we need servers, we need compute nodes, we need disk storage, we need switches. And most importantly, as you know, this equipment generates a lot of amount of heat. And this need a very complex and sophisticated cooling system to reduce this heating and keep these machines working efficiently. Because, you know, the technology was developed as such. Now on compute nodes, you can find one compute nodes with let me tell you, with 40 cores for each compute nodes. And all these gathered are needed to calculate or process the data using very complex algorithms. Then these servers use thousands of kilowatt per hour. I mean, server, compute nodes, disk storage, all these combined within one data center. Let's do a quick exercise. Imagine that looking at 10 major companies in the world, each company has, let's say, 20 data centers spread around the world. you can imagine how many servers, compute nodes, disk storage we will use at the same time, and what is the energy consumed to make these machines working. It can take maybe thousands, millions of kilowatt per hours are consumed to keep this machine working, and I mean achieving this company's objectives. Now, what I call digital transformation is the way we think to gather all this equipment or find out alternative solution to bring everything to cloud solution. What means cloud solution? You know, I will not make advertising for the current cloud provider because all of you know them very well. I'm thinking about Microsoft, Google, Amazon, Alibaba, who are, I mean, the main player in the market. But the idea here is, if we gather and we accept to work with this cloud solution, alternative solution, we will reduce a lot of the number of servers, the number of machines that needs a lot of energy to consume. Why? Because on the cloud, we will use the capacities as per our demand and as per our volume of work. If I have work, if I have a project to process, if I have a very complex interpretation to do, I will request exactly what I need. And since a lot of companies will use this cloud, so the machines are more optimized. I mean, they will be busy all time, but doing the job as per demand by the other customer. In opposite, for the companies with their own data center, they don't have all time a huge volume of work to do. Sometimes we see a drop in activity. So the machines are not so busy, but they keep consuming energy because it's not easy to shut down the machine over the night and go back in the morning, put them on and start rebooting the system, which takes a lot of time. And it's not even good for the system itself and the health of the system itself. But in the cloud, since, as I said, we have a lot of customers. They are working on demand. Principle. They can optimize the usage, but we reduced the 200 or the 1,000 data centers spread around the world into one cloud system based in any location, working on our projects, and then it's automatically reduce a lot of the usage of energy by a significant percentage. I can't tell you the exact number, but it's very significant because the spread of system capacity is very huge around the world. This is one of the things that I would share with you. I mean, the digital transformation is very important and can have a very positive impact on the environment and reduce the CO2 emission. Now, the other techniques or other way to help this CO2 emission reduction is the techniques that we are introducing. Mr. Nabi and Mr. GACI talked a lot about that. I mean, artificial intelligence and machine learning. I can tell you, for example, on the processing side, you know, the depth imaging process, it's a it used to be a very heavy process because it uses a very complex and sophisticated algorithm. On top of that, you know that the main elements that we work on during the depth imaging process is the update of velocity model. It's the basic of depth imaging. And you know, at certain stage, we need to generate the common image point and see how the reflectors are flattened. And we picked it and we try to correct the RMO. And this process can take several updates. It can go up to 5 iterations, 6 iterations, depends on the complexity of the area and our knowledge. And the human being is used to do this work. I mean, pick the common image point and get this done. And you imagine if the survey is too big, the fault is too big, so it takes weeks or maybe a month to get it done. With machine learning, we reduced this timeline by almost 60%, which is a very, very important reduction. Yes, as a service company, we think about cost. Reducing time is a reducing cost. But meanwhile, we can think about the time we reduce it on the usage of servers, of compute nodes. And this consequently has an impact on reducing the energy consumption and, of course, reduce CO2 emission, because you know the electrical power comes from the fossil energy. And as you can see on this picture, also for the interpretation, now machine learning is doing a very, very good job in providing us with more accurate interpretation with a minimum time. And this can be done also on the inversion side, on the stratigraphy. But the bottom line, that what I invite you to keep in your mind is reduced duration with these new techniques means reduce system usage, reduce energy consumption, then reduce the gas emission into the environment. I mean, coming back to the story that I started this talk, it seems a small contribution, but if each individual make an effort in his domain of expertise, and we gather and we see thousands, 100,000 or million people act as such, what will be our planet tomorrow? It will be in much better situation. This is mainly what I wanted to share with you. And sorry, it was a very short presentation, but since it's a discussion, I hope that we will have more discussion after this presentation. That's it from my side, and thank you very much for giving me this opportunity again, and thank you for your attending. Thank you.
Thank you so much, Mr. Meddour, for this presentation. As you said, we now fast forward the discussion. As we told you in the first, anyone have a question, raise your hand after I call your name, unmute yourself and ask Mr. Amine here and Mr. Meddour here can answer your question. I have some question in the chat box. If I can read them or anyone want to talk? We will wait, just maybe they are preparing their questions. So I think I will start with the question in the chat box. This is a question for Mr. Amine. He said, what's the name of the software Halliburton used in the geophysics data interpretation?
Yeah, so we are using decision space platform. Decision space platform can handle all the different disciplines, and basically for this kind of interpretation that I was showing today, it's called decision space geoscience, DSG.
Thank you so much. So here we have another question. Assisted origin interpretation is available on DSG Discap version.
This is web-based, so it's a cloud-based application, and it's directly connected to decision space. If you have a project in decision space, you can sync the results, and you will have the results so currently the horizon assisted interpretation is separate to decision space, the geoscience application. So it's a cloud-based application.
Thank you. We have another question. How horizon paths are connected both sides of complex fault system? Yeah.
Sorry, can you repeat it, please?
How the horizon paths are connected both sides of complex fault system? Like this question. I don't know who asked. Mr. Mohammed Khan, if you can ask.
I can see it. So mainly the patches would be let's say connected based on the reflection of the seismic data. So if there is some changes in the reflection, which is the case in some of the cases, we will be correcting this using the geo model that we talked about it. That's why the combination between the patches and the geo model is a key to reduce this uncertainty when you are interpreting the stratigraphic layers.
Thank you. We have a lot of questions from Mohammed Khan. If you can just mute yourself and ask Mr. Amine, he's here to answer you. Yeah, he asked a lot of questions. Another question here: assisted horizon interpretation can handle the bench horizon case. The horizon case.
Yes, of course. And in the case study that I have presented, so there was some pinch out interpretations that we put together since we were interpreting in a complex regime field. So there were some stratigraphic layers where they used to have some pinch outs, and the combination between the geo model and the patches helped us a lot to interpret those discontinuity in the interpretations.
Okay.
And one more thing I can add is that lately we have added the complex geology part to this algorithm. So if there is a multi-Z interpretation or a change in, for example, a reverse fault, it could be also handled during this algorithm as well.
Sorry.
I think I've seen a question just above, sorry to interrupt you, which is about the different algorithms if we are sharing them in the GitHub. So we have a platform dedicated to all the machine learning algorithms. So there is some free machine learning algorithm, and there is all others that are much complicated that are for, let's say, for business fields or to be solved.
Yeah.
Yeah,
So
you can just go to ds365.io, and it's a platform that you can see all those algorithms.
We have another question from Abdul Qadir. Can we use the gradeless method and scalable Earth modeling for a dynamic modeling?
So this is like a utopia. So we cannot, for time being, we cannot do it. But for time being, we take this griddless model, we grid it, or to make this dynamic model. But what we are working on it currently is that directly we can run simulation or dynamic model directly on this griddless model. This is something that we are on an advanced level of development, and could be ready in. I'm not saying soon, but it could be ready in probably couple of months.
Okay, thank you. So ladies and gentlemen, please, it's just a panel. You can, as I said, raise your hand and ask your question, because I'm reading here the question. It's not the role of this session. It's supposed to be to ask, and yeah, it's supposed to be to discussion. So please, it's okay. You can ask.
Can I go ahead?
Yes, of sure.
Okay,
go
thank
ahead.
you, Jumana. So thank you so much, Mr. Nabi and Mr. Meddour, for your wonderful presentation. Actually, I have a question for Mr. Meddour. I really liked the story about the hummingbird who was saying, I'm doing the best I can. My question, sir, is that do you think that we are nowadays, we are really doing the best we can for this energy transition, since that nowadays the business is going above everything, and that there is, even if the global warming has never been as high as today, people are thinking about, for example, exploring shale gas.
Excellent question, Abdul Qadir, and very a complex one, actually, to be honest with you. We are doing our best at different business sites. I believe on human capacity to overcome this situation, because we have not another planet where we live. So either we improve the situation of our planet, or we will disappear. Let's go back to the business. What we are doing, all this transformation, digital transformation, is aiming for two things. I will be honest with you: to reduce the cost first, but also to help reducing the emission of CO2. That's why I insisted on using cloud, because we will reduce the production of IT equipment and reduce the usage of the power, because everything is concentrated with very few providers. I can give you an example. For example, in Schlumberger, we developed a digital platform called Delphi. In this platform, for processing, we can talk about other stuff, but for processing, you can connect using internet into this platform, Delphi, and you click on our processing software, Omega, and you start building your workflow and run your processing as normal. So if you work in any oil company, you will not need for a server, you will not need for compute nodes. Everything is done outside your site. And other oil companies can do the same. You can interpret, you can do your time processing, your depth processing using cloud. What you receive is just the results. First, you reduce your own cost because you will not spend the money in acquiring new equipment, which costs a lot. You will not deal with maintaining this equipment. It costs a lot as well. You have to hire, I mean, IT engineers. You have to purchase licenses to keep maintaining the system, and on top of that, you have to keep, I mean, powering this equipment all the time, and this has consequences because the power you are using is coming from fossil energy, and unfortunately, this fossil energy is emitting a lot of CO2 into the environment. This is what I wanted to show you. It is, if we compare it to what transportation is emitting or other industry is emitting, it's too low. But if you go back to the story, we are doing the best we can do, and if every individual do the same, the best he can do, the total will be something that will impact positively to the environment. And then I will end by making some comments on the shale part. Look, this is, I'm a scientist, right? And when we talk about shale, there are a lot of politics behind. We have to say it, to tell it as it is. You know, we are dependent, as Algerian now, we are dependent on exporting hydrocarbons to develop our economy, to sustain our needs, right? All our fields, I mean, conventional fields are declining. What is the alternative solution? I will not answer, but I'll keep it to you guys, young people, to answer. What is the alternative solution? Thank you very much.
Thank you, Mr. Meddour, for your explanation. Yeah, this is actually a good question. What is the alternative solution for us today? There is a lot to say about it, and as you said, this is going be above the scientific side, so we can't really think about an alternative solution safely, if I may say. Okay, so thank you so much for your answer.
Welcome.
We have here hand raised. Musab, you can unmute yourself and ask your question. Go ahead.
Thank you. Hello, everyone. Thank you, Mr. Meddour and Dr. GACI, Mr. Nabi. Thank you for the presentation you delivered. I actually like the example of the hummingbird that you, Mr. Meddour, mentioned earlier. It's really representative of a successful operation. Let's say, my question to you, Mr. Nabi, what is Halliburton doing from its part to achieve successful energy transition? As we heard from Mr. Meddour, Schlumberger is already participating in that.
Yeah, so as you may know, that carbon storage, or CCUS, is one of the key trends that we are also working on them lately. You may probably, I'm sure that we are hearing a lot about CCUS, what can be done, but there's a lot of projects or assessment are done everywhere in the world. But to be honest, here in Algeria, we are way forward compared to other people, other regions in the world. Probably one of the first CCUS project was done in Salah in 2008. So I believe here in Algeria, the regulations are already in place to such a solution for CCUS. And to answer your question about what we are doing, so we are building a CCUS team based on experts from different domains and different disciplines. So we are having this team that is assessing organizations, operators in different locations around the world to assess in a first time, or accompany these operators and organizations to reduce or implement securely and safely carbon storage projects. In the same way also, I mentioned also Neftex, and Neftex is one of those solutions that are working heavily with geothermal solutions. So we are trying to help investors and also organizations to transition their energy types from the hydrocarbon energy to a clear, more clean energy like geothermal energy. And last one, there is a new, let's say, we call it PSL, like product line, but it's a segment in Halliburton. It's called Halliburton Lab. And what we are doing in Halliburton Lab is that we are dealing with startups. So we start working in the US currently. I hope that we can have it here in Algeria as well, probably soon. So and Halliburton Lab is working on with startups, with some to fund and invest in those startups that having new ideas to reduce CO2, to reduce emissions, to also to create more clean energy. So there is a, let's say, different initiatives in different domains, but I could also mention that those are different domains, and I also have or hand also the idea of Mr. Meddour about the use of cloud to reduce the energy and to reduce also the amount, the big amount of energy. This is also something that we have as so hardware users. We have to also to optimize. You can imagine that we can all have big and huge cars, but at the end we are using the car like 1 hour or a day or 2 hours a day, and all the day it's parked somewhere. But this type of solutions can be optimizing the use of energy and also helping to optimize this use of energy as well.
Thank you so much, Mr. Nabi.
Okay, we have another question from Jeffrey. Can you unmute yourself and ask your question? Mic is yours.
Hello, good morning. Thank you for this presentation. My question for the Halliburton presenter, because we are talking for student chapter here in University of Boumerdes, you have any training course or any for the student or any software or free license for the student?
Yes. So in university, are you talking about University of Boumerdes? Mr. Jafri? Yeah, I assume you are talking about University of Boumerdes. So what we have is that in University of Boumerdes, Reservoir, and Wergla, we have offered the complete solutions in drilling, reservoir, geoscience, petrophysics, economics, all different disciplines. We have the solutions there. It's installed. There is a missing part, which is the training. We will try to work together with our teams and with the SPE, SEG in Boumerdes, in Reservoir, and Wergla to try to have like a collaborative training between all the different universities. I'm willing to get back to the University of Boumerdes with a plan. I hope we can have a plan for a training session for you guys. But yes, the licenses and the softwares are there.
Thank you so much, Mr. Amine, for your answer. I think now we can pass for Mr. Hadi. Hadi, you can unmute yourself.
Okay, thank you. Good morning, everyone. First of all, I would like to thank all of the Mr. GACI, Mr. Amine, and Mr. Nabil for the excellent presentations. My question is directed to Mr. Nabil. Nabil, thank you for the insightful lecture, as always you are. So very precise. As SAB, as an oil and gas service company, do you have any partners that you are sharing the digital transformation and net zero objectives, like Sonatrach, for example? Don't know, just for as an information.
Thank you very much, Hadi, and nice to talk to you. Yes, we have partners, but outside the country, in Algeria and let's say in North Africa. You know, we have this situation where the data residency is an issue. I mean, customer is very, very keen to keep data in the country. But why I insisted to give this presentation to the young team, this is to prepare them to new thinking for the future. Now the world is a village, you know, everything is accessible and there is nothing highly confidential. And also there is agreement between the cloud provider and Schlumberger. So the data is very secure. But we started talking to our customers. Some of them start to understand the need by giving them the cost reduction of such behavior, and also from environment perspective, we start seeing some positive feedback, and hopefully we will get to that. But outside the country, of course, we worked a lot with Equinor, British Petroleum, Legacy, and Anadarko. We did a lot of projects, mainly in North America. I can tell you, mainly the work is done on cloud basis. I mean, we access Omega, our posting software, through Delphi, our digital platform, to do the work, and it works very well. Even in the Middle East, we had some experience that. Hopefully, it will happen in near future here in North Africa.
Yeah, I hope. Yeah. Thank you for the.
You are welcome, Hadi. Thank you.
And Yeah, good luck for the future. Thank you.
Thank you very much, Adi.
Thank you very much. Thank you.
So, any other question, ladies and gentlemen? Mr. Amine and Mr. Meddour, waiting for your question before end this panel. So we will wait just a few minutes. If anyone have another question.
Okay, can I go again? Okay, I have another question for Mr. Meddour. Do you think, sir, that this post-pandemic recovery is misleading us? Since that we saw that during the pandemic, a rise in public demand for renewables, but now countries are thinking again about oil and gas, looking for economic stability. So it is kind of misleading us.
I completely agree with your statement. We don't need to lie between us. We still need fossil energy. This is unfortunately the situation right now. And maybe you noticed how big was the demand after the pandemic, because with the economy recession during the pandemic, I mean, now all the big companies, the countries are looking to recover what has been lost. Then the demand of energy is too high. However, meanwhile, there are some good improvement in energy transition. We see a lot of work that is done on the transportation side with the new regulations. I'm talking about what is happening around the world, of course, and this bring, let's say, hope to see more engagement from the countries to a next step, which is to reduce significantly the CO2 emission. And also from the ONG sector, oil and gas, I think a lot of actions are taken already. Mr. Amine Nabi was talking about Halliburton. Same thing is happening in Schlumberger. There is a real wish to head to the gas emission reduction. So yes, unfortunately, there are two statements. Unfortunately, energy fossil is still dominating the energy market, but meanwhile, I'm not desperate. I see on a daily basis a lot of effort made on the energy transition. I hope I answered your question.
Totally. Thank you, Mr. Meddour. Thank you.
Welcome.
We have again Mr. Jeffrey. Mr. Jeffrey, can you hear me?
Yeah, I hear you. Only one remark. Hello?
Yes, go ahead.
Only one remark for Abdelkader for shale gas. Shale gas, for example, here in Algeria, is the cost of drilling of well is very high compared. Let me tell you, for example, in desert in Algeria, in Adrar especially, the cost of the well of the gas around $14-12 million. In shale gas, multiply the cost by 10 because this depends on the technology, the material outside from the country. Shale gas for us, for Algeria, forgetting now. This is my only remark. Thank you.
Okay, thank you. Thank you, Mr. Jafri, for your addition. Actually, I understand what you are talking about. Thank you.
Thank you so much for you. Thank you so much for you all. And I think it's the time to end our panel. Thanks for all the participants they are attend, and thanks for Mr. Amine. Thank you so much for your presentation. Thank you so much for your time, your energy. Mr. Meddour, also, thank you so much for your time and for your great presentation. And I would like to thank Mr. GACI. He left us sadly. He had emergency and he couldn't continue the session to the end, sadly, I said. So I would like to thank you all. Thank you so much. And that's it. Mr. Amine, Mr. Meddour, anything to add?
I would like to thank you all for this opportunity to talk to you and get insights from you all. It was a real pleasure to get with you. Thank you very much.
Thank you so much, Mr. Meddour. Thank you so much. If you want to add anything else.
Thank you very much. It was a pleasure to be with you. Hopefully we will meet again next time.
Yes, it's an honor to having you all here today. Thank you so much for you. And I said, this is the end for this session, this panel, and thanks a lot for your attend. That's it. Thank you so much.
Thank you. Thank you. Bye-bye.
Time. Goodbye.
Thank you. Bye.
Bye.
For the participants, please just don't forget to fill the attendance sheet. And that's it for today. Thank you.